Hello and welcome back. My name is Corey, and you're my rubber ducks for the evening. And this is the series of episodes where we are creating Tang. That is, we are building a custom programming language from scratch using nothing but C++ and a few basic tools. Well, I'll say basic, they're powerful, but the tools like Flex and Bison and Google Test as our unit testing framework, and ICU for our Unicode support. And as I've said multiple times on here, if we don't build it, it doesn't exist, and we're doing everything. So we've started from the very beginning with nothing, and slowly but surely been adding features to our language. In the previous episode, we added the ranged for construct to our language where we could iterate through a collection. And we implemented that with arrays. And I said, at the time, we've done the hard work, but it doesn't exist yet for strings. So the first thing we're going to do today is we're going to add the ranged for support for strings. That's the first thing. And then the second thing we're going to do is we're going to forgot what I was saying. Add the range for support for strings. And the second thing is we're going to improve several places in code where it's been out there and it's got to be done. But I think the string thing is going to happen rather quickly today. That's the hope. So we will jump in. And as I've said before, there's nothing up my sleeves. This is 100% live coding, which means you see all of my mistakes in all their glory. And let's see, on the left-hand side, we have our status is there's no code changes there. And if I say git log, the last commit that's there was the commit for episode 53. And so, yeah, we're on a clean slate. On the right-hand side, let's do a make clean to remove everything and then just start with a new compilation. So make test watch, there we go. And while that's working away, on the left hand side we're going to let's add our test case first. And that is so the test case is going to be for adding the string, and then we're going to need to edit the include for computed expression string and the source for computed expression string. But I know I'm going to want to copy computed expression array and source for computed expression array. Excuse me. So we're going to start there, and let's look for the word range. There we go, the ranged for. And we did a lot of work already. You can see here iterating through an array, iterating through a temporary array, through a two-dimensional array. What happens if it's not a collection that we can iterate through? What about the break? What about a continue? All of those are just fine. Now we're going to, there we go. Let's iterate through a string. And so now A is going to be a string, and let's call this ABCDE. And instead of num, let's call it char. That's not a reserved word in this language. Forget the continue, and we're just going to print char. But we will also print how about a dash, just so that we can see that yes, we are in fact doing something. And what should the output be? Well, we'll fill that in just a moment. But for the moment, all the tests pass. Why? Because it didn't print out anything. if I just left an A there. It's going to fail, but for the wrong reasons. All right, so, in fact, C, D, E, dash. That's what it should be. And now, let's start working on the string thing. So, we know that computed expression string. Let's go into for, and we're going to copy the get iterator and iterator next. All right, and that's, where do we have that? After the slice. Yeah. All right, so we've got this get iterator and iterator next. That's fine. And now we're going to let's assign index. There we go. Get iterator and iterator next. This is the computed expression string. We'll put it after slice. This is going to be string, and this will be string, and so what needs to be different here? First of all, we've got our get iterator, and if I ask for the get iterator, I'm just going to take in a computer, I'm going to make a computed expression iterator and passing it myself, really, but it's the garbage collected value that points to me. Yeah. Is that right? Yes, we're good. Okay. Now, what about iterator next? Well, that's an index, and what I need to do here is I need to do this needs to be val.substr, and we're going to do index comma 1. Yeah. Now, the question is oh, I was going to say, is it going to be that easy? Probably not. This should be a return garbage collected, make computed expression string, and pass in that. Oh, it's still not liking something. Oh, contents.size. This should not be the word contents. It should be val, and I think it's actually length. Now, what else am I messing up? Computed expression iterator was not declared in this scope. Fine. So we need computed expression iterator and computed expression iterator end. ITERA iterator and computed expression iterator end. Just like that, it's passing. We're at the 10-minute mark. Well, less than 10 minutes. But so let's go back to our tests then, and let's iterate through a temporary string, and E F G H I J K L M N O P Q R S T U V W X Y Z. Okay, and we're going to say a : 3. All right, and now should be A, D, yeah. G, no, what? j-m-p-s-v-y-. Okay, so it works with through a temporary string, which is always a good thing. And the last thing I'm going to check is for an empty string. What's it going to do? Through an empty string. And all we had to do is say that, and it should be empty. And also, I'm going to add here p1 dot get result. The reason is I want to see this will fail, but it should be, I believe, just a null. Oh, no. It's the last thing that was. In other words, I just want to make sure. No, that makes sense. I just wanted to make sure that it's not an error. So if I did a is equal to 3. Oh, well. Oh, I don't propagate the error out. Okay, never mind. Don't need to do this line. Simple enough. So, there you go. When you do the work to lay a good foundation, then the subsequent stuff comes quite easily. That's always a good thing. So, see what our changes are. This is nothing unexpected. Okay. And what are we going to say? We're going to say add range for support to computed expression string. Simple enough. All right. Now, let's do some other stuff. And can I do it this way? Can I say get grep and nope. What I wanted to know is what I'm looking for. So I don't see a way of, well, I'm just doing really quickly, but I'm not seeing a quick way of limiting it to a certain directory. So I'm just going to go into source. No. Include. And I'm going to say get grep friend. Because I've been naming some things as friends, and I want to get rid of that. Now the friend ostream output, that's perfectly fine. I'm not worried about that. But I don't like declaring the friend class for float and integer. So what we're going to do, we're going to need to edit the source for need to back up. So edit the include for computed expression float, the source for computed expression float, the include for computed expression integer the source for computed expression integer. And let's see, the source for computed expression array and the source for computed expression string. Edit. Oh my goodness. I said we're going to edit it, and that's where my brain went. All right, so computed expression float. All that we're going to do is find this friend thing and delete it. So I'm not going to like it, but that's fine. Oh, okay. So there's one thing we're going to need to do now. Since we've got this, what do we, computed expression float, we need a, what's our type here? A float t. So Tang float t is our return type, and it's just going to say get value. Will that work? Yeah, get value. And we'll call that a const. All right. And computed expression float. But just go down to the bottom. There we go. And we'll say, there we go. And this is there we go. Computed expression float get value, and all that we need to do is say return this arrow val. Simple enough. All right, now I'm going to go back and just to yank that out, let's go to those. Now we've got this, instead of float, it's going to be integer t, our integer type. And I'm just going to copy these lines and now go to the end of, this should be integer t, integer, get the value, this arrow val. And then last, not last, but okay, so why do we need these? Well, first of all, let's back up to, there we go. So when I need the value from an integer, here we go, right here, the right hand side, I'm saying it is an integer and I need to get its value. So what I'm going to say is get value instead of just val directly. All right, and I can do the same thing here. And that should be okay. And now we're going to go forward and do the same thing when I'm in an integer and wait, I'm going back. I did it for that one. Do I have to do it? Is there a million of them? Yeah, there is. Okay, let's start at the top. I'm just going to look for Get value. Okay. Just look for the word integer. Why not? There's one right here. There's one here. Oops. There we go. All right, where's the next one? Integer, get value. The next one, integer, get value. The next one. All right, see if all of those have passed so far. So we go up and float compiled. So we're good. And now the integers where we're starting to get errors. That's fine. I think I'm going to look for the word float and just do the same thing. Get value. Get value. Oh, wait. There. Get value. Same thing here. Got to do it twice. Get value, and here. There we go. Get value. That worked with integer. And now the question is, what about string? See, that should not have worked. Yeah, don't know why it didn't try to rebuild it. Probably because I'm missing a reference somewhere. Get value. Get value. All right, all of those should have compiled, and then I know array. And it's pretty much going to be the same thing. So what I'm wondering is, can I do... No, I think it's just as easy to do. Yeah. See if all of those worked. So far, okay. And in the meantime, I'm just going to exit out of here and see what our changes are. We added get values to those. Conv begins, ends, and all of those things. And of course, the nice thing about refactoring, you've got unit tests, so everything runs and everything is still working. It's always a good thing. And let's see, so let's see. Reliance in oh, I can't do this. Well, I mean I can, but there's one other thing I need. I need help text. So the include for computed expression float and the include for computed expression integer. Yes. Right here. So helper function to get the I don't like that. Sure. And we'll say at return. All right, and copy that. I'm going to put that here. Now I feel better. Refactor to computed expression float. Sure. Not too bad. What else can we do? Well, there's a couple things I'd like to do. Let's just look at an example. Let's source computed expression anything and source computed expression, integer. So if there is an error, and these would be in our dunders right here. I don't like the fact that we've got don't know how to add these values. over and over. So if I look for dunder add, oh, it's right there. Don't know how to add. I don't like that. Can we do this instead? Return Can we do that? Return the default error is what I'm getting at. The answer is yes. All right. So how many places can we do this? Look, on the subtract, don't know how to add these values. Don't know how to multiply. Don't know how to divide. You may complain at the moment, Corey, you're just copying it. I know, it's so that I don't lose it. That's fine. All right, so equal. This one needs to be, what am I in? Less than. Modulo. This should be divide. And this one, by the way, there. Put a blank line in for consistency. This one should be multiply. This one should be subtract. And add. And so now we're not ever declaring, am I ever declaring an error? Cannot divide by 0. I am okay with having that error. Cannot modulo by 0. That's fine. And that is it. Let's see if we pass all of our tests still. We do. That is a change I want to make. I've never liked the fact that I was copying error messages. And all right, so here's what we're going to do. I'm going to vim the source of all computed expression everythings. And let's see. Computed expression.cpp is buffer 4. So I don't need this. So I can delete it. And now computed expression integer, I just changed that, so that's in buffer 7. All that I'm going to do is remove that, go to the first buffer, and now look for the word error. Well, that's an okay error. Error. And I'm going to use this dunder nothing. Okay, and just going to use this to, don't know how to slice. Well, that's going to be the dunder slice. That doesn't need to be there at all. Index out of range, that should be fine. Index out of range. All right, so I'm not going to do this one yet. I'm going to go to the next buffer and just continue what I was doing. See, that one's easy. Oh, the error class itself. I think all of these can be fine. Yeah, I think all those are fine. Oh, I'm in the float. There's going to be a lot in this one. Subtract. Now I'm in multiply. For divide, cannot divide by 0. Cannot divide by 0. Else the default. Don't know how to compare. Don't know how to compare. Okay. I don't even need it for the iterator. Or the iterator end. Uh-oh. Which one am I on? I'm on number 10. Okay, so go back to B2. There we go. So don't know how to slice. Don't know how to slice. We'll fix the indentation in a moment. Don't know how to slice. Don't know how to, there we go. Keep going. Default is don't know how to slice. Don't know how to add. Oh, this is less than. This is an equal. All right, now, so computed expression array. So what is this? This is index. Oh wait, this is slice. Slice. Still in slice. That one doesn't need to be there at all. This one is assign index. All right, we'll save that one. Oh, okay. 65. Why? Because some of these don't have a right-hand side. Or it's index. Okay. So, and 82. This should be begin and skip. Okay. '87. '104. Yeah, what should this be? Begin and skip. All right, and 121. And then last but not least, 172. This is index and value. Okay, everything's still passing. That's a good thing. And let it tell me where all the errors are. We're just gonna, oh, I could search for the word error. This one right here. This is, again, index. That should be index. Okay, this is a slice, so it's begin, end, and skip. Oh, wait, is it? Come on, where does this start? Yeah, slice. All right. This is add, so equal anymore. Yep. 71. Somehow I missed this. These are all slices. Okay. I don't know of a faster way of doing this. I wish I did. Oops. And I missed these. These should be should have done that. That. And this is slice. This is another one. Hit the wrong thing there. All right, that one's down. Now we know, so we've only got 6 more left, and some of them actually don't have any changes now, I don't think. So I did a search for the dunder, and this should be equal right-hand side. Okay. That's all in that one. Yeah. That one doesn't have anything. That one doesn't have anything. Oh wait. I thought I said right. All right, so this is an add. So we will dunder add here and remove that. Let's look for the next one. Subtract, and what are we in? Oh, that we're in the computer expression float. That's fine. There'll be a lot of things in here, but that also means this is the only other big one. We don't have to slice in this one. Divide. Less than. The next one should be equal. Is that all of them? Always want to double check. And in the meantime, left-hand side, this one. equal. Don't know how it got by. Start again. All of these look normal. Actually, I'm going to go back up to the top, and what I'm going to do in verifying, it's index, and that says index. Slice, 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 slice. Slice, slice. Oh, and that one was slice, slice. Oh yeah, that one was getting rid of just something that was unreachable. Assign index, assign index. Equal, equal. Equal, equal. Add, add. Subtract, subtract. Multiply, multiply. Divide, divide. Less than, less than. Equal, equal. Add, add. Subtract, subtract. Multiply, multiply. Divide, divide. Modulo, the next one should be modulo. Less than. Equal, equal. That's fine. This is index, index. Slice, slice. A whole bunch of slices, I'm sure. Slice, 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 slice. This is equal, equal. Okay, that's all of them. So they're all right. All the tests are passing. We have successfully done that, which means we're now going to be using consistent error messages. So there we go. Probably should have called that parent class, but that's all right. All right, so is there anything else that I think I can tackle in just this little bit of time? I mean, there's always a lot of stuff, but I wanted to change the error messages. I wanted to get rid of the friend class stuff. And I tell you what, let's do this. Let's remove the docs. Remake them, and let's look at them and just see if anything stands out. WSL view, and what do we need for WSL view? We need to know where it is. Docs, HTML, index. Should bring open our browser and all of this stuff. Let's look at our class list. All of this stuff. Let's look at our files. What's in the Unicode string? That's fine. You know what? I want to know if there is a way to show hidden data, like protected and hidden. And the easiest way to see that, it would be include get grep private. So all sorts of these have private things. So okay, including AST node. So there we go, AST node. And now let's do a quick search. Doxygen include private. Extract private to yes. Let's try that. So our doxy file, what is it called? Extract private. Let's okay, so if the extract all is set to yes, Doxygen will assume all entities in the document are documented, even if no documentation. Will be hidden unless, oh, okay. But I do want, so if I just do this, so static members of a file, I don't think I want that because, well, static hides it from the outside world. It's an internal one. Local classes is yes. Local methods, oh, Objective C. Anonymous namespaces, no. Scope names, compound reference, show include files, yes. Force local includes, yeah, inline info. Okay, this is, I think we've gone beyond. We're probably fine there. Let's rerun. My computer sounds like it's taking off. Oh wait, refresh. There we go. And are we seeing stuff? Oh, private, there we go. Location is showing up. Good. The virtuals, that's fine. think I like this. And let's call this actually, no, I think I want to go ahead and do it this. What about protected? Nope. All right. Should we ever worry about changing the project number? Thinking maybe we should at some point. Oh well, we'll not worry about this at the moment. Go back to this, git commit, and we'll say change oxygen setting to include private members and private virtual functions. That should work. And if I also do WSL view of the docs/LaTeX and then refman.pdf, we should see 443 pages. All sorts of lovely stuff in here. Yeah, that's good. So I think at this time, that's probably a good stopping place. Oh, and nothing else there. So let's you know I never know what episode we're on. Episode 54. 054. It's there. And now if we do this clock, where does this put us? 8,400 lines, 2,600 lines of comments. That's fine. And all right, again, showing progress as usual. And of course, for me, the best part is that adding the ranged for strings went so easily. It allowed us to get some other stuff done that we needed to get to do as well. So, as I've always said, personally, that usually means to me that I've designed something correctly, or at least in a good way. If when I need to extend it, it doesn't take a lot of work to extend. It took a lot of work to get it there, but it didn't take a lot of work to extend. So that's makes me feel happy. All right. So having said all of that, I think it's time that we'll wrap this up. And once again, thanks for joining me, and hope you have a great day.